Okay, so here's the last question in our revision for our surds, indices, and logarithms test. And this is where we kind of bring that growth and decay together with our logarithm knowledge now in order to solve exponential problems. So this will be our extension type question in our test. The first thing I want to go over is to remember exactly what this part of our expression is. So the question says that the population of seals with regards to time is given by the relationship 80 times 1.15 to the power of t, where t is the time in number of years. Now, we can tell from this, like we said before, that if we have the number or the constant that's put to the power of t minus 1 is 100%, means that each year the population is increasing by 15%. So we can understand what this term in here means. But what I want you guys to be able to do is also to write your own expression. So if you, this is our initial population here. And we've shown previously that that's because where t equals 0, this part of the expression goes to 1. So the first term gives you your initial population. So if I was to tell you that there was an initial population of 80 seals, it was increasing at a rate of 15% per year, you could create this relationship yourself. You would know it was 80 times 1.15 to the power of t. So just keep that in mind. You can do them both ways. Okay, so we know it's a growth problem. We know it's an exponential problem. So what is the question asking us? So what is the time for the population to double in size? Now we know that our population initially is equal to 80 seals. So 2 times our initial population is 160 seals. So that's what we're asking. How long does it take to have 160 seals in our population? So the question is, what is the value of t where 80 times 1.15 to the power of t is equal to 160? So straight away we can see that if we divide both sides by 80, we get 1.15 to the power of t is equal to 2. Now before we knew how to use logarithms, that would be pretty much as far as we went and we wouldn't be able to solve this. But now we can use our logarithms by taking the log of both sides of the equal sign. So the log of 1.15 to the power of t is equal to the log of 2. Now our logarithmic laws say that if we have a value to a power, that's the same as multiplying by that. So that's the same as t times the log of 1.15 is equal to the log of 2. So therefore, t must be equal to the log of 2 divided by the log of 1.15. And we're just putting brackets around that just to make sure we don't think that that decimal point is a multiplication. And just to make it very obvious, we'll write in here that we've divided both sides by the log of 1.15. So now, using our calculator, we can punch in log of 2 divided by brackets log of 1.15, and we will get an answer close to 4.96 years. Now 4.96 years is a pretty good answer, but we're mathematicians and we want to be as clever as we can about our answers. So we will recognise that that means 4 years plus 0.96 times 12 months. So 4 years, and if we multiply 0.96 by 12, we get 11.5 months. So this is correct. This is just showing that we have a little bit better of in-depth understanding of how we use those units. So it's just a bit better, but it's still correct. Okay, the next question is asking, well, what is our percentage increase in population during the first 4 years? So it's saying, what's our increase been when t equals 4? Now remember that the increase in population is all determined by that second term in our relationship. So if we write our relationship out again here, times 1.15 to the power of t. So this part of the term doesn't change. The increase or decrease is always governed by this part of our relationship. So we want to know what the percentage increase is the population during the first 4 years. So if we put 1.15 to the power of 4, we get approximately 1.75. Now we said before 1.15 is a 15% increase. So 1.75 gives us a 75% increase. Because we would now multiply to get the final population. So the population after 4 years would be 80 times 1.15 to the power of 4, which would be 80 times 1.75, which is a 75% increase on 80. Just like 0.15 is a 15% increase on 80. So we don't need to find out, if we're just looking for how much the increase is, we don't have to solve this to know that it's going to be a 75% increase. So our solution can be found without actually solving for what the population is after the 4 years. Okay, good luck with your revision and I'll see you at school.